just keep going. So, product rule, quotient rule, and chain rule. Of course, this will not work when I first open it up. So I open it up twice, 10th time. And this is only employing the power rule to defeat these. So they really are just dress rehearsals for the real thing. And here I go. 14 problems to contend with. We will do them two at a time. So here I go. Right, dy by dx. I'll differentiate the first one and leave the second one alone. And then differentiate the second one and leave the first one alone. All right, and now I don't know if they want me to expand it, but I'm going to do it just because I like it. So that would be minus 9x to the 6, minus 12x to the 6, so minus 21x to the 6, plus 6x squared. Okay, now f prime of x, differentiate the first one and leave the second one alone. And now differentiate the second one and leave the first one alone. So it should be like that. And now that will give me a cubic, that will give me a cubic, and so I bring them together. So minus 12x cubed and minus 4x. And now we check. Everything must be checked. That is all correct, and that is good. Dy by dx equals, differentiate the first one, and now differentiate the second one. And now bring them together. Fifth power there. So 16 and then 8. And so that creates 24. X to the 5. That would be a cubic term and then another cubic term over there. So negative 8 plus 12. Negative 8 plus 12. Well, that's 4. Right there. And so now f prime of x, differentiate the first one, giving us 8x cubed. And now differentiate the second one. And now bring them together. Fifth power and another fifth power there. All right, so 8 and 4 makes 12. 12x to the 5. And that's a cubic term right there. And that's a linear term right there. And we check. Oh no! Darn it. Okay, wait. I didn't see it. I'm going to try and fix it. How the heck did I get this wrong? Okay, I'm just going to start again because it's small enough to start again. But it's just me getting used to this, right? So differentiate the first one. and I get minus 8x cubed, and the second one is left alone. Then I differentiate the second one, so I get minus 4x. And the first one is left alone. And now bring them together. So that creates a fifth power, and that creates another fifth power. So that's 16 plus 8, which is 24x to the 5. Next, that's a cubic. And that one is not. Oh, I see it now. Okay. That should be good now. And now this has got me paranoid, so I'm going to check this. Okay, differentiate the first one, leave that one alone. Differentiate the second one, leave that one alone. Okay, and then expand, and hopefully I do it correctly. Fifth power, boom, done. Cubic, done. And linear. Okay, time to check. Correct. Okay, I like that. Hopefully I can get these two correct now. So here we go. F prime of x. Uh-oh. Excuse me. I did not mean to sneeze, but it just came upon me. So, okay, differentiate the first one, and we get 25x to the 4. Leave the second one alone. And now differentiate the second one, so I get negative 10x to the 4. And leave the first one alone. And now expand. So I will get the 9th power there and the 9th power there, and then we must combine them. So we get negative 50, take another 50, so negative 100x to the 5, to the 9, to the 9, to the 9. And then we will have negative 75, negative 50. Negative 75, negative 50. So negative 125x to the 4. I believe. Okay. Okay, now we must be more careful. So differentiate the first one. And there you go, with the second one being left alone. And now differentiate the second one with the first one being left alone. And now expand. Okay, so I don't know, so I'm just going to literally do it term by term. So 12x to the minus 1 minus 9x to the minus 4 plus 36x squared minus 12x to the minus 1. And now, because I like to put it in descending powers of x, so I'm going to have 36x squared. Take, I know that people don't like it like this, but no, I actually do want to keep it in this, I don't know what you call it, pseudo-polynomial format. Okay, and these will cancel out. I can't believe I didn't see that. Okay, they will cancel out, so that's all good. Now we check these, and that is correct, and that is good. All right. One. Differentiate the first one. Okay, so now it's getting a little bit harder. The thing is, it's not like hard, it's just keeping track of everything and not making a mistake. So next up comes negative 6x. And now, upon expansion, one must keep track of what's going to come out. You can do that, and then you can fuss around like tracking the indices and all that stuff, or you can just go full on and just expand it out and then just clean it up afterwards. And that's what I'm going to do. I'm going to do FOIL on this pair right here. So I'm going to get 24 x to the 5 minus 16 x cubed minus 30 x cubed plus 20x. And then I'm going to get plus 12 x to the 5 minus 30 x cubed minus 24 x. And now I shall bring everything together. There are my fifth powers, and they will be brought together to give me 36x to the 5. And there are my third powers. Well, hold on now. Which must be brought together. So I get minus 46 minus 76. And then the rest are linear terms, and so I get minus 4x. And of course, you could factor out 4x from the whole of that if you wanted to, but they didn't ask you to. It's just a polynomial. That's all there is to it. Okay, dy by dx here. That felt a little bit too smooth, too good, right? So maybe I did get that wrong, but I don't know. Differentiate the first one and leave the second one alone. And then differentiate the second one and leave the first one alone. Okay, this becomes negative 20x to the 4 plus 20x cubed, and that is done. I now expand there, there, and there, and now FOIL over here. So the first term will be negative, so it'll be negative 20x to the 8. And then outside, plus 20x to the 7. And inside, minus 60x to the 4, plus 60x cubed. And now gather. 8th powers, there and there. Put them together, and we'll get that, negative 36x to the 8. 7th powers, there and there, and put them together, and you get 40x to the 7. And 3rd powers, or cubic terms, there. And wait a minute, hold on, stop the presses now. There's a 4th power right there. Okay. That's good, that's nice. And now the rest are cubics, so put them together and we get 80x cubed. And now we check this pair and we see if we did it right. Okay, that's correct, and that's good. That's correct, and that's good. Okay, a little bit more to go now. Differentiate the first one and leave the second one alone. So 20x cubed minus 6x times that, and differentiate the second one and leave the first one alone. And now expand. So FOIL on the first, so FOIL with the first pair of brackets. So negative 100 x to the 5 plus 60 x cubed plus 30 x cubed minus 18x minus, hold on now, minus 50x to the 5 plus 30x cubed plus 10x. And now to gather everything. Fifth powers, there and there, and put them together, and we get negative 150x to the 5. Third powers there, there, and there, and bring them together, and we get 120x cubed, and the rest are linear, so we get negative 8x. And now we have something that looks like this, something that looks like this. So what do? Well, we remain, stalwart and recognize that inner term there is that negative 7x to the 2/5. So I differentiate the first one. Negative 14 over 5. There. There, like that. Okay, now just carefully apply FOIL to the first pair. Minus 40x to the 4. Minus 40x. Minus 28 over 5. And that would be x to the minus 9 over 5. Minus 56 over 5. X to the minus 3 over 5. That's the first one done. The second one, please. Minus 60x cubed. Minus 42. Now that's x to the 2/5. And if I add on 1, that would mean that it's to the 7/5. So it'd look like that. And finally comes this one. And now we have to gather up everything. So the highest power involved here is the fourth power. So that takes care of that. And next in line will be the third power. So that takes care of that. And then comes this one and this one. Oh, no, it doesn't. Oh, my goodness me, it does not. That one actually comes way further down the line because it's negative. So I must be careful. Okay, so now we combine that linear, the one there, and the one there. So it's going to be 14x. And then comes this one, followed by this one. There. Okay, now to check. Okay, the ninth one was fine. No, I dispute this. Oh no. Oh no. Oh, goodness me. See, you differentiate just one term wrong at the start, and it all cascades. The errors cascade. So all of this must be done again. But we're going to do it again because we're going to get it right. So that there is 6x squared. And now to expand properly. That's to the minus 3/5. And so that would be to the minus 9/5. Okay, so 2 2/5 makes 12/5. And that makes 54. All right, so now to combine carefully. That's valid. That one was done correctly. And then comes this. And then comes 54x squared and this linear here. And then the last two. All right, now to check. Okay, we're in agreement about that. 238 over 5, huh? Okay, we're in disagreement about that. 54x squared, we agree. That we agree, but that we don't agree. Okay, so it's clearly it's this term that's causing an issue, isn't it? Oh, goodness me, that's obviously not the case, is it? So 15, so it's 12 over 5. Oh, goodness. They actually match up. So that was done incorrectly. I understand the nature of the error now. So that should be 12 over 5. That should be a positive power, and it should be the 12th power over 5. All right, just to be clear here. All right, so I get that. Okay, and now to... Did I dislocate my shoulder? That feels strange. Okay, now for this one here. They really are not letting up. Differentiate the first one and leave the second one alone. Differentiate the second one and leave the first one alone. So 20x is a 4 plus 18x squared. Just like that. And now expand. And now order. There's the first. One, 2, 3. Okay, 150, take away 24 is 126. And then negative 36 at 54, makes what? 18. There. Okay. I know that you're supposed to do the product rule here, but I would actually find it easier just to expand and then just do it. But to get used to the product rule, I will try it. And then the next one. So let's just see if I can do them all in my head, but that's going to give us 4 terms, and that will give us 3 terms. So do you really want to chance it? Really? Think about it logically. No, it's less error prone to just do FOIL. So we just do it. Okay, so there we go. That one and that one come together. That one and that one come together. That one and that one annihilate, and that one gives us that. And check. Okay, those are correct. Good, those are correct. All right, I love it. Okay, the final boss. Okay. Don't know if I'm ready for this. Go on, try it. Okay, fine. Differentiate the first one. Two-fifths of 10 is 4. And the second one is left alone. And now I'll differentiate the second one and leave the first one alone. Okay, now expand carefully. All right, so I'm going to get that. Followed by that. Okay. Now I did this one a lot wrong last time, this step. -3 fifths plus 2. That's 1 2/5, which is 7 fifths. Okay. I think I did that correctly. Next. Z, I nearly got it. Okay. Okay. There and there. So we get negative 42x to the 5. The cubic term. Seven fifths. So 4 and 20 makes 24. And 16x. And this. And we check. I did it. Okay, awesome. Okay, a classmate claims that f times g prime equals f prime g prime f prime times g prime for any functions f and g. Show an example that proves your classmate wrong. Okay, what's like the absolute simplest counterexample I could cook up? Just trying to think what's good. Okay. The prime of, which is the prime of x to the 5, which is 5x to the 4. That's the left side. That's the left side. And now we shall consider the right side. Okay, so it's going to be, the prime of x cubed multiplied by the prime of x squared. Okay, which is 3x squared times 2x, which is 6x cubed. Not equal as claimed. Airtight, watertight, and all the other kinds. Rigorous reasoning right there. And they used a linear term and a constant term. That's kind of cool. All right, so product rule has been finished. Now on to the quotient rule. Now, what is the quotient rule? Well, the quotient rule is a way of finding the derivative of one function divided by another function. To find the derivative, like d by dy by dx, d by dx of f over g, then what you do is you do d by dx of u over v, you do v prime u minus u prime v over v squared, I think. Is that right? I recite it to myself so many times, but I always forget the quotient rule. And here's the thing. Is that okay that I forget it? No, it's not. I understand that you can derive the quotient rule by doing chain rule and product rule, but I need to have it first hand on memory. U over v is u prime v minus uv prime, u prime v, no. v du dx minus u dv dx, v du dx, v times u dv dx, v times du dx minus u times dv dx all over v squared. Right, now am I seriously going to do all these? Well, I should do some and then save them for later because I don't want to eat up too much time with this. It's just a lot of writing. So, differentiate the bottom. No. U dv dx. V du dx. V du dx. V du dx. So the bottom times by the derivative of the top minus the derivative of the top. No. The bottom times the derivative of the top minus the derivative of the bottom times by the top. That's quite musical. I like that. Okay, so the first term goes to nothing. So minus the derivative of the bottom times by the top. I get 8x cubed. Times by 2 all over that squared, which is that, I believe. Okay, practice that rule again, the musicality of it. I know it goes v du dx minus u dv dx, like that. It's very musical, very nice, but I want like better phrasing in my mind. U over v. So the bottom times the derivative of the top, take the top times the derivative of the bottom times the derivative of the top, take the top times the derivative of the bottom. That's quite musical. I'll do it one more time. The bottom times the derivative of the top, take the top times the derivative of the bottom. Takes too long to say, but it's it's catchy. And then that's the music, but then you have to feel it. Oh, squared. Hello. Okay, we'll check those first two. Check the first two. Okay, that's accurate. And I don't know how many I'm going to do here, but we'll see. Because we don't want to eat up too much time. I want to do the chain rule before I go out. Okay. So it goes the bottom times the derivative of the top minus the top times the derivative of the bottom. So in this case, minus 5. 12x squared, just like that. And that sorts out the top, the numerator. And down here, you have to square that denominator. So this leads to a nice, beg your pardon, negative 60x squared all over 16x to the 6 plus 32x cubed plus 16. That's nice. And it's all divisible by 4, is it not? Okay, so let's do that. So there. All right, so what about this one now? The bottom times the derivative of the top minus the top times the derivative of the bottom, like that. So, okay, that would be this times the derivative of the top. And what's that? Well, that's 12x squared minus 6x. Minus the top times the derivative of the bottom, which is 20x to the 4. And all of that is over the square of this. So to clean this up, this will have 6 terms. Let's see if I can do it in my head. I know it's going to be very awkward, but I'm going to try anyway. There's my 7th power. And there's my other one. So 48 minus 80, which is minus 32. Okay. There's my 6th power right there. So I get my plus 60. Okay, so I've already used up over here, everything over here. So cancel that out in my mind. Next. Okay, I think minus 48x squared plus 24x. Maybe wrong, but you got to try. Okay, square this. 16x to the 10 minus 32x to the 5 plus 16. And everything is divisible by 4 once more, but I really don't want to do that. Write that out. So I'm about to see if I actually got it right in the first place. Okay, problem 3, correct. Problem 4, once you divide by 4, so close. But you know what's not right? This. Sorry, has to be fixed. Okay, well, let's see, I've got a minus sign there, and then a minus sign there. So that will give me 60x to the 6. But I forgot to take away this one. Hello. 60 take away 24 is 36. So here we go. So that should actually be 36. Okay. Right, okay. Instead of just exhausting my hand and my mind and my soul and spirit and everything else about me and just doing all of these, I'm going to take it piecemeal, spread out. And I'm going to go over to the chain rule and juggle them mentally. So I will return. I put a bookmark in my book to come back tonight. Except it has so many links on it. And then I go to the chain rule. Okay. Here it comes, the chain rule. What does the chain rule say? When you have one function which is fed in to another, you must be able to differentiate this. And here's how you do it. You go from the outside in. Differentiate the outside function and leave the inside one alone. And multiply by differentiating the inside one. But it really does not seem clear like what you're doing in this case. That's why I think you should learn the chain rule for a 3-layered function, not a 2-layered one. And the reason why is because then you tune into the pattern. Okay, right, okay, so here's how it works. Are you ready? Differentiate the outside one. And leave the inside two alone. Times derivative of the middle function, if you like. Leave the inside one alone. Times derivative of the inside. Look at that. It's like I'm going from the outside in. Like an onion. So, I will try it out. Okay, so the outside function is where I'm raising something to the power of 5. And that's very easy for me to differentiate. It's literally just 5 blah to the power of 4. If something is raised to the power of 5, when I differentiate it, it ends up looking like this, doesn't it? 5 times blah to the power of 4. So in this case, 5 times this thing right here, all to the power of 4. And then multiplication symbol, and then differentiate the inside function. When I differentiate x cubed at 3, constant term disappears, and x cubed turns into 3x squared. Like that. And then clean it up a little bit. So when I do that, I'll get 15x squared. X cubed at 3 to the 4. And that's good. That's good. We'll try again. Okay. Differentiate the outside function. And leave the inside one alone times the derivative of the inside function, which is this. And then clean it up. There. Right? And we check. We always check. Okay, these are not correct. Uh-oh, sorry. I didn't multiply negative 15 by 3 correctly. All right, so I try it again. That should be negative 45. And is that fine now? Yes, it is. Okay, good. Okay, do these two with no mistakes. No mistakes. Differentiate the outside function and leave the inside one alone. And then differentiate the inside function. And so I get, wait. Oh, sorry. I thought this was the same question. And then differentiate the inside function. So minus 15x squared and clean it up. So minus 45x squared times that thing. Just bringing that and that together. And putting that one at the end. Number 2, differentiate the outside function and leave the inside one alone. And now times the derivative of the inside function, which is 10x. And clean it up and bring it together. And it's all good. And we check, and that's correct. And that's correct. And that's good. Okay, so who's next here? Well, a lot of functions are. So we're just going to do 6, and then we'll pause it and come back. Come back some other day. It's a quarter. So quarter minus 3/4 times minus that. So what will this look like? What will it look like? It will look like minus 3x cubed over no. Mm-hmm. All good. Oh, I'm actually enjoying this. I'm going to do the chain rule a little bit more. There. There. Mm. Mm-hmm. That's right. That's right. Oh, man. Okay. Product chain, I guess. Differentiate the first one. Leave the second one alone. Differentiate the second one and leave the first one alone. And then here the inner, which is minus 8x. So I don't know. They don't want us to expand it, surely not. Not sure. All right, so they want as much of a factorization as I can get. Mm-hmm. Okay. That one. Minus 32x. Oh no. Oh man. Oh, so you have to expand it out. Not doing that right now. Right, okay, this is just good enough. This is sort of just getting in touch with them. Yeah. So it's all good. It's all good. Right, be well, be well.